Welcome to Lesson 8.1. In this lesson, we will be talking about simplifying expressions with zero and negative exponents, as well as evaluating exponential expressions. Please remember, this video does not take the place of practice or asking questions in class. These are the rules and the key concepts. So, for every non-zero number, a to the 0 power is going to equal 1. Some examples. 5 to the 0 is 1. Negative 2 to the 0 is 1. 1.02 to the power of 0 is 1. 1/3 to the power of 0 is 1. Any non-zero number taken to the 0 power is 1. Okay, so I could have $1 million. If I take it to the 0 power, it is still 1. Now you have to be careful here. Notice what is happening here. Notice that the negative 2 is in parentheses, and that is taken to the 0 power. The same with a 1.02 to the 0 power. We're going to get into some problems in which this might pose a little bit of difficulty if you're not careful as to what is being taken to the 0 power. Remember, anything directly in front of the exponent is the base. So in this case, our base is negative 2. If this were written a little differently, we could have a different answer, and I'll explain that in the future. And then we have negative exponents. So for every non-zero number, a, and an integer, n, a to the negative n is going to give you 1 over a to the n. Think back to our powers of 10 and how that can be applied. So notice here we have 6 to the negative 4th power. That just becomes the reciprocal 1 over 6 to the 4th. If I have negative 8 to the negative 1, notice what happens here. Okay, the exponent comes down and it loses its negative sign. I like to think of that negative exponent as its ticket to the basement. Okay, so let's look at a few of them here. We now have 3 to the negative 2. We're going to make that the reciprocal, 1 over 3 squared. Okay, well, what does 3 squared mean? 3 times 3. What is 3 times 3? 1/9. If you were to punch this directly into your calculator as it is, you will see that you get the decimal version of 0.1 repeating, which is fractional form of 1/9. What about negative 22.4 to the 0? Remember, everything inside the parenthesis is taken to the 0 power, so that's just going to give us 1. If we have an exponential function, notice how we have the negative exponent in the denominator. Okay? You can think it, remember, x to the negative 3 is the reciprocal 1 over x to the 3rd. So now we have this big, ugly fraction here. Think about what it means. If you think about it, this is just a big division problem. 1 divided by the fraction 1 over x to the 3rd. How do I work with fractions in division? I take the reciprocal and multiply. What is 1? 1 is just 1 over 1 times x to the 3rd over 1. What does that really give me? X to the 3rd is my final answer. Have to think about how division and fractions, if you're weak on that, please, please, please work on your that quizzes and come and see me. But fractional sense is extremely important, especially with negative exponents. Let's move on to the third example here. Oh, we're at a quick check. I apologize. So this becomes 1 over 3 to the 4th. 3 to the 4th is 81. That's 1/81st. Anything to the 0 power is 1. Becomes a little trickier here. Negative 4 to the negative 3rd becomes 1 over negative 4 to the 3rd. Think about what that means. 1 over negative 4 times negative 4 times negative 4. Negative 4 times negative 4 gives us a positive 16, but when we multiply it by negative 4 again, we get 1 over negative 64. So we actually have a negative answer here, okay? But again, it's not a negative answer because of the negative exponent. It's a negative answer or simplified expression because of the negative 4 inside here. Think about the meaning. I've got 3 negative 4s multiplied together in the denominator. Let's use our exponential properties to evaluate an expression. Here we have 4x squared y to the negative 3rd. There's a couple of ways you can do this problem. What I recommend is clear the expression of negative exponents first. Get rid of those negative exponents. So if I have y to the negative 3rd, just think about that y to the negative 3rd. What does that become? That becomes 1 over y to the 3rd. Everything else stays in the numerator because only y is taken to the negative 3rd power. Remember what is directly in front of it. Okay? So we have 4x squared times 1 over y to the 3rd. We can simplify that to 4x squared over y to the 3rd. Okay? The y to the 3rd is in the denominator. We've got 4x squared over y to the 3rd. Now we can plug in 3 and negative 2 for our x and our y. And again, what is directly in front of the exponent is going to be taken to that power. So 3 squared is 9. 4 times 9. Negative 2 to the 3rd, again, is negative 2 times negative 2 times negative 2. That gives me a negative 8. Simplify that a little bit more. I get 36 over negative 8. I can reduce that to, if I divide them both by 4, that gives me 9 halves, and that's a negative. And again, I don't like to leave my negative in the denominator, so I'm going to move that up. Okay? Go ahead and try the quick checks. Hope you paused the video, tried the quick checks on your own. Let's look at the results here. A is going to be 11 over m to the 5th. Again, only the m is taken to the negative 5th power, so only the m to the 5th comes down. Notice the negative exponent is now gone, and it's a positive. The same with s to the negative 4. That's going to come down into the denominator, and everything else is going to remain because only s was taken to the negative 4th power. In example C here, or quick check C, we have 2a to the 3rd. The negative exponent basically comes back up if we start to use our reciprocals. And then in this case, we have the n to the negative 5 that has to come down into the denominator, but we need that 1 as a placeholder in our fraction. All right, here we're looking at quick check example 3. And we have n to the negative 3rd times w to the 0. That w to the 0 becomes the 1, and the n to the negative 3 comes down into the denominator as n to the 3rd. 1 over negative 2 to the third becomes 1 over negative 8. And again, I like to write the negative sign in my numerator, so I have negative 1/8. Example B, 1 over nw squared. The n to the negative 1 comes down. That becomes 1 over negative 2 times 5 squared. 5 squared is 25. So I have 1 times negative 2 times 25, which is 1 over negative 50, or negative 1/50. W to the 0 again becomes 1. N to the fourth remains. I substitute in negative 2 for n. Notice I'm only replacing the negative 2 for the n. I use parentheses because whatever n is, it needs to be taken to the fourth power. So in this case, it would be 1 over negative 2 times negative 2 times negative 2 times negative 2. That's 4 negative 2's, which gives me a positive 16. Have to be careful there, okay? If it were written a little differently, we might have a different result. Something to leave you with. If I wrote negative 2 to the fourth power, what is directly in front of the exponent is taken to the power. The negative is not. In this case, I would have something that looks like this in expanded form. My answer becomes negative 16. Again, because only the 2 is taken to the fourth power, not the negative. If it were written this way, now I have negative 2 times negative 2 times negative 2 times negative 2, which gives me a positive 16. Please notice the difference. This is extremely important because most of our mistakes are going to happen with things like this. Again, complete your post-video checks, ask questions, and try some practice problems. Good luck. Have a great day.